Okay, hello everybody. Welcome to the next video. We're going to be talking about atomic structure today. So last time we talked about the periodic table and how you can use it to find all the different elements that exist in the universe. What we're going to do today is we're going to talk a little bit about what makes those elements different. What is it about those different elements that causes them to have their own little box on the periodic table? And so we're going to talk about the structure of atoms, okay? So the smallest little bits of matter that exist in our universe are called atoms. You can think of them as like the smallest Lego in a big bin of Legos, right? Everything that we see around us, including our bodies and the world around us, is made of individual atoms that are put together in certain configurations. Atoms themselves are made of 3 subatomic particles. Okay, subatomic means smaller than atoms. So they're made of 3 particles. Okay, so all atoms that exist are only made of these 3 things. And you've probably heard of these before: protons, neutrons, and electrons. Each element on the periodic table contains different numbers of protons, neutrons, and electrons. That is what makes the elements different from one another. Okay, is these differing numbers of protons, neutrons, and electrons. This is the general model of what an atom looks like. It's not a perfect model. In fact, in many ways, it's actually kind of wrong, but in other ways, it's pretty accurate. So this is what we're going to go with for now. We're going to learn a lot more about the structure of an atom as the course continues, but this gets the basics done for us. In the center of every atom, there is a nucleus, okay? The nucleus is not some sort of separate object. It's just the protons and the neutrons that are sort of together. They are referred to as the nucleus, okay? So really, it's just the protons and the neutrons that are found together in the middle of an atom, and that is referred to as the nucleus of the atom, okay? The electrons, on the other hand, are sort of zipping around on the outside. They exist outside of the nucleus. And like I said, in the future, we'll talk a lot more about electrons and what they're doing specifically. But for now, just know that they exist on the outside of the atom in what are called orbits or orbitals. Okay? The subatomic particles have some properties. I don't need you guys to memorize this. This is just here for us to look at one time and for you to reference later. Protons are found in the nucleus, right? The key thing about protons is that they are positively charged, okay? So they have a charge which is positive, okay? They're positively charged. Charge is kind of like magnetism, okay? So like a magnet, you guys know how a magnet has like a north pole and a south pole, and if you take a magnet, like 2 magnets will like come together, or sometimes if you take 2 magnets, they'll push apart from each other. That's the same sort of concept as charge, okay? 2 protons that have positive charge would like repel away from each other, okay? But if you have a proton and an electron, okay, because electrons are negatively charged, they would be attracted to each other. So that's the general rule there with charges, is that opposites attract and like things repel. Okay, so the protons are found in the nucleus and they're positively charged. The neutrons are also found in the nucleus. They don't have a charge. Their charge is neutral, okay? So some people write this as like the number 0 to represent that there's no charge. I just wrote Na for not applicable, okay, or not available. There really is no charge to a neutron. Both of these 2 particles here, the proton and the neutron, we're going to say that they have a mass of 1, okay? So protons and neutrons have some weight to them, okay? They have some mass, and they're both found in the nucleus. The electrons, on the other hand, have essentially 0 mass. They do have some mass, but it's so small that compared to a proton and a neutron, their mass is basically 0, okay? And so we're going to treat it as if their mass is basically 0 throughout this course. Okay, and like I said before, electrons are negatively charged. 1 proton and 1 electron perfectly balance each other out in terms of the charge. Okay? All right, and like I said, electrons can be found outside of the nucleus, not in the nucleus. Okay, just to remind you of what we looked at last time, each entry on the periodic table has some information, and we're going to use this information on the periodic table today to tell us things about those different particles. Okay, so just to go through this really quickly, the number at the top of each box, that's called the atomic number. We have the symbol and the name in the middle, and then there's a number at the bottom, usually with a decimal place and some extra numbers here, that is called the atomic weight. This is also referred to as the atomic mass. Okay, and that's what I'm going to refer to this as moving forward. Okay, so actually erase this from your brain, right? This should say atomic mass. Okay, so the atomic number is always a whole number that sits up at the top of the box. The atomic mass is the total mass of that element, and it is found at the bottom of the box. Okay, so what we're going to be doing today is using the periodic table to find the different numbers of each particle. Okay, and these are the rules that I'm going to ask you to use. Okay, we're interested in the number of protons, the number of electrons, and then later the number of neutrons in each element on the periodic table. And I'm not going to have you go through the whole table, that would be crazy, but we're going to be looking at a couple of different elements on the periodic table. Okay, the first two things here are super easy. Okay, the number of protons in an element is always equal to its atomic number. Okay, so for example, here in hydrogen, because it has the atomic number 1, I could say that it has 1 proton, and that's true. Okay, so this number up here is just always equal to the number of protons. The number of electrons is equal to the number of protons. Now we're going to go with that for right now. This is not always true, but for right now we're going to say that this is true. Okay, this will change later. All right, but for right now we're going to say that the number of electrons is just equal to the number of protons. So once again, for our hydrogen example, if the atomic number is 1, that means there's 1 proton, and that would also mean that there's 1 electron. Okay, because the protons and electrons are the same number. Okay, now the only tricky part about this is finding the number of neutrons, okay? And sometimes it is a bit tricky. The atomic mass, okay, which is that number at the bottom, the atomic mass is equal to this, the number of protons plus this number of neutrons, right? And that's what we don't know yet. You can rearrange this equation to solve for the number of neutrons, and this is what you get. The number of neutrons is equal to the atomic mass minus the number of protons. Okay? So, for our hydrogen example, that looks a little strange, right? The atomic mass is 1.008 minus the number of protons, which we said was 1. So the number of neutrons is 0.008. That doesn't make a whole lot of sense. So there's one other last little thing that I want to tell you about. For now, we are going to round the atomic masses to the nearest whole number. Okay? So what that means is that for this example here, we would want to round this number to the nearest whole number. 1.008, that would round down to just the number 1. Okay, so the atomic mass for hydrogen, for us, for right now, is just going to be 1. Okay? Here are some other examples of how you might round numbers on the periodic table. 6.94. The rule is you want to look here at this digit right here, the one that's right of the decimal place, only this number right here. If that's a big number like 5, 6, 7, 8, or 9, then it causes this to round up. So 6.9 would round up to 7. If this number is small, like 0, 1, 2, 3, or 4, then it causes this number to round down or just stay the same. Okay, so 12.01 would just round to 12. And then this is kind of one of those that's in between here, 35.4. Okay, so that number there, 4, is smaller, so it causes this number to just stay at 35. If it was 35.5, then this would round up to 36. Okay, you guys are more than welcome to ask me some questions about rounding. It can be a little tricky depending on what the number looks like. Okay, so this page right here is what you guys are going to find really useful as you're working on your assignment for me today. in our Canvas course, you'll find the assignment called Atomic Structure. When you click on this, it's going to ask you to make a copy of the assignment, and it looks kind of similar to the assignment that we did yesterday or last class on using the periodic table. Today, however, we're only going to be looking for really these three things and a few other pieces of information, but that's not too hard. Really what we're focused on here is the number of protons, neutrons, and electrons. I've got one filled out here as an example for you, but let me go ahead and work another row for you, all right, to show you exactly what's going on here. Once again, I'd like you to change your text color. Okay, so I'm going to change this to blue so that it's easily distinguished from what was there already. Once again, each row is a separate problem. Okay, so each row is talking about a separate element on the periodic table. For this one, the starting information is the symbol AU. So I'm going to pull up my periodic table and make this a bit bigger. So we need to find the element that has the symbol AU, and then we're going to fill in all this missing information. Okay? So here is AU right here. Okay, so I have a lot of pieces of information here. This is the element gold, and it's got the number 79, and then there's this big number down here, which I'll talk about in just a minute. So let me write a few of these things down. So the element name is gold. Next box is the atomic number. So that's the big number at the top, 79. And then the next box here is the atomic mass. And there's even a reminder here that says, hey, round this number, round it to the nearest whole number. So the atomic mass, this is always going to be the number at the bottom with the decimal places, and we want to round this to the nearest whole number. This is 196.9, so that's going to round up to 197. Okay, so make sure that all of these numbers here in this column are rounded to the nearest whole number. There should not be any decimal places here. Okay, so these first four pieces of information, these come from the periodic table itself. Okay, the next three pieces of information, you're going to need to use this slide here in the notes, which you can find in Canvas. You're going to need to use this slide here using these rules to find the number of protons, neutrons, and electrons. Okay, the number of protons is equal to the atomic number. Okay, so the atomic number is 79. That means I have 79 protons. The next rule was the number of electrons, and that's equal to the number of protons, which is also equal to the atomic number. Okay, so remember, the protons and electrons are the same, right? So over here, electrons, that would also be 79. Guys, that's why I've highlighted these three columns for you, is to just help you remember that rule. These three numbers should always be the same. The atomic number, number of protons, and number of electrons should always be the same. Okay? At least for today. And then the last rule was the number of neutrons. Okay, and this is that tricky one. Okay? So the number of neutrons is equal to the atomic mass minus the number of protons. Okay? So if I go here, the atomic mass minus the number of protons, well, let me just type that up here in my search box. 197 minus 79. Press equal, press enters, 118. Okay? You're also more than welcome to just use your phone as your calculator. There you go. Okay? So that is an example of how to solve one of these problems. Let me show you one of the harder ones, okay, where you don't have this starting element information here. So let's scroll down a little bit. Let's do this one right here. Okay, so it's the third from the bottom. The only piece of information that we have is the number of protons, 14 protons. So let me change all of this text to blue real quick. Okay, so if I know the number of protons is 14, remember that the number of protons is equal to the atomic number and the number of electrons, right? So I can fill this in, 14 and 14. And if I know the atomic number is 14, then I should be able to look on the periodic table and find it. Here it is. Oops, it's too much. There we go. Number 14, silicon with the element symbol Si. Okay, so let me fill that in. Silicon Si. Okay, it's also asking me for this, the atomic mass. That's the number I need to round. Right, so that's this big number down here, 28.0. Okay, so that's going to just round to 28. And then once again, a lot of times your very final step is going to be finding the number of neutrons. That's equal to the atomic mass minus the number of protons. So the atomic mass minus the number of protons, 28 minus 14, that's also 14. Okay, and you can use your calculator for that if you can't do that in your head. Okay? All right, so that's pretty much it, guys. There you go. This is the entire assignment for today. It's only one page. Just as usual, I'll be here after you guys get started to answer any questions you might have. Thanks a lot.